Hey everybody, what's up? We are talking inverses in composition of functions. We teach them together because they are rather intimately related because you need compositions to be able to prove inverses. So we started the year, and if you go digging back, and if I ever get the learning cards recorded for those, which I hope to do second semester, we talked about inverses from a table, where you have like one table to another, and all you do, remember, you're going to switch the x and the y values, okay? So for example, if I have x and y, and 0 goes to 2, and 5 goes to 1, the inverse of that is going to be 2 is going to take you back to 0, and 1 is going to take you back to 5, okay? Inverses from a graph, remember, I should probably do that in black. So inverses from a graph, if I have this, you have a line that follows y equals x. So if I have a picture that looks like this, the inverse is going to look very similar to it. And if I tilted it sideways, you'd see the mirror image of it. And then the last one is, and this is the new thing for compositions, to find g of f of x, when f of this, you're going to plug in, I'm going to take this, I'm going to plug it into g, which so that I'm taking f and plugging it into g, which means I'm going to take this whole thing and I'm going to plug it in where x is. So g of f of x is equal to g of, now f of x is equal to 2x plus 3, so that's going to take that place. And then everywhere I see an x, I'm going to write 2x plus 3 in its place. Now, if that was more complicated, I would probably multiply that out. I'm not going to do that for sake of time. Plus, it just looks snazzy having a little binomial there squared, right? So down over here, when you're solving for an inverse, what you need to do is that we're going to go through and you're going to swap x and y, okay? Just like above, swap x and y. That is an ugly one. So just like we did up above with the tables, and also technically with the graphs, since we're swapping x and y, I should have labeled those. I am so sorry. So we're going to swap x and y. Now the only difference is then we're going to then solve for y. Okay, so I'm going to rewrite this. This becomes y. I'm going to do the swap. So x is going to equal 4y minus 5. Divide through by 4. So then y is going to end up equaling x plus 5 over 4. And then what you should do, because let's face it, you want to make this look amazing, is then I'm going to write So the other thing I'm going to do is I'm going to write an inverse notation. So then the y is going to become f inverse of x over that. Now the two things that they're going to ask you to probably do on ACTs, SATs, on your tests, is that they're going to ask you to prove that two things are inverses. And that's where the composition comes in. Now to prove that two things are inverses, you have to say, what it says is this: if I compose it in one direction, that's going to equal the same thing as doing the other direction. And all the time it's going to bring you back to x, which is the whole goal. Okay, my original input goes to an output, and then that output comes back to that output goes back to the original input when we run it through the inverse. So to prove it, you have to do both. Some people like to try to change this, don't do this, into square root of x plus 3. That's finding an inverse, but by definition, you need to do it this way. So you're going to have to do two inverses. So we're going to prove the composition of f of g of x, the same thing as the g of f of x, and that's going to equal x. Now, if they say prove or disprove, as soon as you have something that doesn't work, you can stop. You don't have to do both sides. But for at least the way that I teach it initially, we do it where you're proving that they always work, and then in pre-calculus, they kind of give you both. So in this case here, f of g of x is going to be f of, and g is x plus x squared minus 3. I'm going to plug that into, so this is going to go in for that x. So I get the square root of, instead of x, I'm going to have x squared minus 3 plus the 3. So the 3's go away. Square root of x squared is going to just turn out to be x. Check. Now some people say, wow, that seems really straightforward and real simple. Do I really have to do it? And the answer is yes, because again, remember, we're building skills here. We're not necessarily doing things really hard because we don't want to do things both hard and trying to learn the skills at the same time. Okay, so then we're going to go ahead and do this the other direction. So now I'm going to plug this into that x. So that's going to become the square root of x plus 3. So then instead of the x, I'm going to write the square root of x plus 3. That's going to become squared minus 3. Square root squared is just the interior. Check. And then I would, especially if you're going into the AP pre-calc stuff, I would say just get used to writing stuff out because you want to be clear that you're saying. And you're going to say yes, f of x and g of x are inverses. Okay. So lots there. Not necessarily the intent to go through that, but hopefully that's helpful. I will put the link down below to all of the lessons and all the cards and all that other stuff. Like, comment, subscribe. You've probably stopped watching at this point already, haven't you? Okay. See you later.